All right, hi, year 11, this is Mr. Lim here, and we're going to go through a limiting reagent acid-base question. Okay, so just remember, you can do lots of these and you just have to kind of look at all the little bits and pieces to make sure you get this right. Okay, so this is the worksheet that we had before. We're going to just do one of these things here. Let's do this one here. Okay, and then maybe we'll do another one depending on how fast we do this one. All right, so let's have a look at that one there. That one there means that I've got, of sodium hydroxide, I've got 20 mils of 0.15, right? And of HCl, I've got 20 mils of 0.25. All right, remember, whenever you're doing a limiting reagent question, you've got to solve for the number of moles of each. Okay, so let's go do that to start with. So go zoom out. All right, so let's go work that out. The number of moles of NaOH. Now remember that this can be via a solid or a solution, so you have to choose the right equation, but for this one here it's CV because it's a solution. So the number of moles is C, 0.15, volume 20 mils, 0.02. All right, that gets you to 0.15 times 0.02, which is equal to 0.003 mole. Okay, remember to label these things as you need to show what you're actually solving. So this is the number of moles of sodium hydroxide that you have. Now we need to work out the number of moles of HCl that you have. Okay, so that one there was 0.25 times 0.02 again. All right, so 0.25 times 0.02 is 0.005 mole. Okay, so that's the number of moles that you have. Okay, now remember, to work out the limiting reagent and to show a limiting reagent, you need to be able to show that you are working with the number of moles of the same thing. So what I'm going to do is I'm going to work out the number of moles of HCl that I need to react with all of the sodium hydroxide. Okay, so the number of moles of HCl that I need in this reaction will be equal to the number of moles of sodium hydroxide that I have times a one-on-one stoichiometric ratio. Remember that you should write out the balanced equation for this one here, and the balanced equation for this one is HCl plus NaOH goes to H2O plus NaCl, and they're all 1-to-1 ratios. So that's that one there. Okay, that one happens to be 0.003 mole. Okay, then you need to show that you can compare the number of moles of HCl that you have compared to the number of moles of HCl that you need. And which one is bigger? The number of moles that I have, because we're comparing this value here with this value here. All right, so the number of moles of HCl that I have is larger than the number of moles of HCl that I need. So I have more HCl than I need, which means that it's not the limiting reagent, it's the excess reagent. And the limiting reagent is the NaOH, is the limiting reagent, right? Okay, so if that is the limiting reagent, we need to work out the concentration of the excess reagent. Okay, so let's move this way. All right, so the excess reagent, number of moles of HCl excess, will be equal to the number of moles of HCl that you have, subtract the number of moles of HCl that you need. Okay, now this thing here you might not have solved, because over here when you do this calculation you can choose either of them, right? And then if these two don't match, then you will have to actually do another calculation to get this value. But sometimes you do it and you get the one that is appropriate, so therefore the one that is in excess, so therefore you don't have to do another calculation, but just be aware that you may need to do another calculation to get the number of moles of the excess substance that you needed or that was used in the reaction. All right, so that one happens to be effectively the have, which is 0.005, subtract 0.003, which will be equal to 0.002 mole, and that's the amount of HCl that's left over. Remember, we want the pH of this, so the pH is the concentration of H plus ions, but we don't even have the concentration of HCl. So the concentration of HCl will be equal to the number of moles over the volume. please make sure that you are able to rearrange all of these equations appropriately. We still have year 12s who struggle with this, so make sure that you can rearrange equations. All right, now here you need to pay attention. You need to really think about what the total volume is going to be. Either you add a solid to a liquid and then the volume doesn't change, or you add a liquid to a liquid and then you have to add the two volumes together. So the two volumes together is 0.04, which is from that 20 mils over here and that 20 mils over there. All right, which then just happens to be, what's that? 0.002 divided by 0.04, which is equal to 0.05 mole per liter. Now, this is a real tricky bit. You have to show that you're converting your concentration of your acid into concentration of H plus ions, or you just have to bring it to a concentration of H plus ions or OH minus ions from your acid and base. Please remember this step, all right? Because sometimes you'll have polyprotic or polyhydroxide things, and you will need to just show that the concentration of one is equal to another, all right? So that makes that 1.05 mole per liter anyway. And then you can work out the pH, because the pH is equal to negative log concentration of H plus, which happens to just be neg log 0.05, which happens to be, what's that? Neg log answer 1.3. Okay, so that's the pH of that particular one there, where the HCl is in excess. Let's have a go at one where the HCl is not in excess. Okay, so let's do something different. Let's do this one. Which one shall we do? This one here. Okay, this one here, let's not do that one. Let's do this one. Let's do this one here. Okay, so if we do that one there, again, we have to do the steps. So we have to work out the number of moles of each. So the number of moles of, NaOH will be equal to 0.35 times 0.035, which is equal to 0.35 divided by 0.035 is 10. Oops, that's not a divide. Don't need a divide, I want a times. 0.35 times 0.035. That's a bit better. Okay. 0.01225 mole. Okay. Then I want the number of moles of, this is the number of moles of NaOH that I have. This is the number of moles of HCl that I have. Okay. Number of moles of HCl that I have, it is 0.25 times 0.015. Right. So 0.25 times 0.015, 0.00375 mole. Okay, number of moles of HCl that I need is equal to the number of moles of NaOH that I have, which happens to be 0.01225 mole. Okay, therefore the number of moles of HCl that I need compared to the number of moles of HCl that I have, which one's bigger? It is the number of moles of HCl that I need. Therefore, the HCl is the limiting reagent. Right? Okay, so now I have to work with the excess of the NaOH. Okay, so how should we do this? Let's move this. Let's move this way. And then let's erase all of that. Oops, let's just get rid of that over there. Okay, cool. All right. So now I have to work out the number of moles of NaOH excess. So the number of moles of NaOH. Now this is the example where I need to work out how much NaOH I need, which would be equal to the number of moles of HCl that I have times 1 on 1. Okay, don't forget that times 1 on 1 over here as well. So therefore that is 0.00375 mole. Then the number of moles of NaOH excess can be solved because now I have the number of moles of NaOH that I have. Subtract the number of moles of NaOH that I need. which is equal to 0.01225 subtract 0.00375, which is equal to 0.01225 divide, not divide, subtract 0.00375. Come on, 0.00375, which is equal to 0.0085 mole. Okay, so that's the number of moles that I have there. I can get the concentration of NaOH now. Right, the concentration of that is equal to 0.0085 divided by the total volume, which happens to be 0.05, 50 mils. Okay. Oops. Answer divided by 0.05, 0.17 mole per liter. All right, the concentration of OH minus ions will be equal to the concentration of NaOH. Okay, don't forget to put that in, right? And then, because now I've run out of room again, right? What shall I do? I should just move all of this across. Move. Oh, that's nice. Everything moved that way. Okay. Okay, so now I have to work out the concentration of H plus ions will be equal to 1 times 10 to the negative 14 divided by the concentration of OH minus. So this is the self-ionization of water equation, right? Just a relationship between OH and H plus. Remember that when H plus goes up, OH minus concentration goes down and vice versa. And so if you have one or the other at 25 degrees Celsius, you can solve for the other. So since I have the concentration of OH minus, I can solve for the concentration of H plus to get me my pH. Okay, so therefore 1e to the negative, 1e to the negative 14. Oops. How do I do this on this calculator? E to the negative 14. It keeps on going. Answer 1 times, no, not times, 1e to the negative 14. Yep, okay, divided by 0.17. I don't think I've done that right. I don't think I have to put brackets around this. New calculator. Divided by 0.17. That's 5.8 8 times 10 to the negative 14. Right? Yeah, that's right. Okay, and so therefore I can work out the pH is equal to negative log that value, which is a very small value. Okay, so equal, yep, okay, the neg log answer, and the pH is 13.23. Okay, which is what we expected because it's going to be excess sodium hydroxide. All right, so that's that. That's examples of how to do some acid-base limiting reagents. Adios.